Hi everyone, welcome back to my channel. This is Mr. Budihas, your online math teacher. In today's video, you will learn joint variation. This is the third type of variation. In my previous videos, I already discussed the first type, which is the direct variation, and the second type, we have the inverse variation. But in this video, I'll be talking only about joint variation. Let's start. Joint variation, it is a type of variation that involves direct relationship of more than two quantities. It is almost similar to direct variation but differ on the number of quantities involved. That is, if any of the independent variables increase or decrease, the dependent variable also increases or decreases respectively. For example, the area of a triangle varies jointly as the base and the height, since the area will increase or decrease if any of the base or height increase or decrease respectively. The two independent variables here are the base and the height. Area is the dependent variable. The area will depend only on the measurement of the base and the height. If the base or height increase or decrease, the area will also decrease or increase. Equation of joint variation. It is a mathematical sentence that describes the relationship between two quantities that are jointly proportional. The statement y varies jointly as x and z is written as y is equal to kxz, where k is the constant of the variation. Just multiply the constant of the variation and the two independent variable, which is we have x and z. Let's translate some statement into mathematical equation. Write the equation for the statement S varies jointly as T and U. The translation for that is S is equal to K times T times U. Next, B varies jointly as C and the square of D. The translation for this is B is equal to K times C times the square of D. Next statement, we have the area of a rectangle varies jointly with the length and the width. The translation is A is equal to K times L times W. Okay, let's try some example, or let's try an example of how to find an equation of a joint variation. If y varies jointly as x and z, and y is equal to 28 when x is equal to 2 and z is equal to 7, what is the equation of the variation? To find the equation of the variation, we are going to transform first the variation statement into a mathematical sentence. We have y is equal to kx times z. That is, from the previous, we have if y varies jointly as x and z. That's the statement. So this is the mathematical translation. And then, substitute the values for y, x, and z to solve for k. Our y is 28, x is 2, and z is 7. Let's find the constant of the joint variation. We have 28 is equal to k times 2 times 7. 2 times 7 is 14. Then divide both sides by 14. So we have the value of k is 2. Then write the original equation, which is y is equal to kxz. Then substitute the value of k, which is 2. Therefore, the equation of the variation is y is equal to 2xz. Now let's try some examples about joint variation. Number 1, if z varies jointly as x and y, and z is equal to 48 when x is 4 and y is 15. What is the equation of the variation? Before I will proceed, I want you to pause the video for a while, then solve it in your own, then compare your answer later. Okay, here's the solution. First is we are going to translate the variation statement into mathematical equation. The statement is z varies jointly as x and y. The keyword is the word jointly. So we'll be using this translation. Z is equal to kxy or k times x times y. The constant of the variation is k, and the two independent variable of this variation is x and y. Okay, after we translate, we are going to solve for the value of k. And we will be using, of course, the values given for z, x, and y. This is our mathematical statement. Z is equal to kxy. Then substitute the necessary values. We have 48 is equal to k times 4 times 15. Multiply 4 and 15, we have 60. 60 times k is 60k, and that is equal to 48. Then divide both sides by 60. So we have k is equal to 48 over 60. But 48 over 60 can still be reducible. So we have 4 over 5. Just reduce to lowest term 48 over 60. We have 4 over 5. That's the value for k. Then third, substitute the value of k to the original equation to find the equation of variation. We have this is the original equation, z is equal to kxy. Then substitute the value for k. So we have z is equal to 4 over 5 times xy. And this is the working equation for this variation. Example number 2. If r varies jointly as u, and the square of v and r is equal to negative 56 when u is negative 7 and v is 8. Find r when u is equal to 3 and v is equal to 15. Now again, I want you to pause the video for a while, then solve it in your own and compare your answer to mine later. In this problem, we are not just going to find the equation of the variation, but we are going to solve for r, in which we are to use the working equation. Okay, first, we are going to translate the variation statement into mathematical equation. We have r varies jointly as u and the square of v. The translation for that is r is equal to k times u times the square of v. Okay, let's continue. Solve for k using the values of r, u, and v. Then substitute it in our equation. R is equal to ku times v squared. And we have negative 56 is equal to k times negative 7 times the square of 8. Okay, let's simplify first the exponent part. We have 8 squared is equal to 64. Then multiply 64 by negative 7, and we have negative 448. And negative 448 times k is negative 448k. Then divide both sides negative 448 to get the value of k. So k times negative 448 divided by negative 448, that is just equal to 1k. So we have k here, and negative 56 divided by negative 448 is equal to 1 over 8. And this is the value for k. Then substitute the value of k to the original equation to find the equation of the variation. This is the original equation. Just substitute the value of k. So we have r is equal to 1 over 8 times u times the square of v. And this is our working equation. Now solve for the unknown. Take note that we are to find the value of r if u is 3 when v is 15. You have r is equal to 1 over 8 times u times v squared. This is the working equation. Then just substitute the value of u and v. And we have r is equal to 1 over 8 times 3 times the square of 15. Square of 15 or 15 times 15 is equal to 225. And multiply it by 3 and 1 over 8, and that is equal to 3 times 225 is 675 times 1 is still 675 divided by 8. And then since 675 over 8 is already in lowest term, therefore the value of r is equal to 675 over 8 when the values of u and v are 3 and 15 respectively. And that's all for today's discussion. Now I want you to solve these two problems under individual practice and kindly comment your answers below so that I can check your answers also if it is correct. And that's all for today. Thank you for watching.